which will give us 40 volts. I. Energy stored in a capacitor. Energy stored, capital W, is equals to half Q squared over capital C, which is equals to half times, in bracket, 240 times 10 raised to the power minus 6 squared, all over 24 over 10 times 10 raised to the power minus 6, which is equals to 1.2 times 10 raised to the power minus 2 joules. Potential difference and electric current. Potential difference, capital V. Potential difference, capital V, between 2 points is defined as work done, capital W, in moving a unit positive charge, capital Q, from one point to the other. Capital V is equal to capital W over capital Q. The unit of potential difference is volt, capital V. Electric current, I. An electric current is the quantity of charge Q flowing per second t. I is equal to Q over T. The unit of electric current is ampere. A. Resistance, capital R. The resistance, capital R, of a metal conductor is the ratio of the potential difference, capital V, across it to the current I flowing through it, or it is defined as an opposition to the flow of charge or electrons. Resistance R, capital R, is equal to capital V over capital I. Memorize I equals to VR, V equals to IR, capital R is equals to V over I. Ohm's law. Ohm's law states that under constant temperature and other physical conditions, the steady current I passing through a metallic conductor is proportional to the potential difference V between the ends. That is, V is proportional to I. V is equals to IR. V over I is equals to R, where R is a constant. Series and parallel arrangement of resistors and cells. Series resistor. Figure 4.7 illustrates the diagram of a series resistor arrangement. In figure 4.7, the combined or total resistance R of the resistance R1, R2, and R3 in series is given by R equal to R1 plus R2 plus R3. I1. Thus, total resistance capital R is the sum of individual resistance. 2. The same current flows in all the resistors. 3. Potential difference capital V is the sum of the individual potential difference across resistor. Example 1. Figure 4.8 shows two resistors 20 ohms and 5 ohms in series. If the PD across both resistors is 20 volts, calculate the current flowing in the combined resistor. Solution. Combined resistance R in series, R is equal to 20 plus 5, which equals to 25 ohms. From Ohm's law, V over R, it follows that I is equal to V over R, which is equal to 20 over 25, which will give us 0.8 ampere. Parallel resistor. In figure 4.9, the combined or total resistance R of resistance R1, R2, R3 is given by 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. One, the total effective or total resistance R is less than the least individual resistance. 2. The total current is the sum of currents through the resistor. 3. Potential difference across each resistor is the same. Example 2. Calculate the total resistance of the circuit shown in figure 410. The diagram of 410. Resistance in parallel. 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Substituting the value, you have that 1 over R is equals to 1 over 3 plus 1 over 4 plus 1 over 2, which is equals to 13 over 12. R is equals to 12 over 13. Example 3. There are 5 ohm resistor connected in parallel having a potential difference of 60 volts and are applied across a combination. Calculate the current in each resistor. Solution. The potential difference across each resistor is the same. From Ohm's law, V is equals to IR. Therefore, I is equals to V over R, which is equals to 60 over 5 ampere, which will give us 12 amperes. EMF and internal resistance of cells. A cell or a source of energy drives electrons through a circuit. Electromotive force. The electromotive force EMF E of a cell is the total energy per coulomb obtained from a cell, or the total energy required to send a unit positive charge around a complete electrical circuit. The unit is expressed in volts, capital V. Internal resistance. The internal resistance R is the resistance of the battery or generator while working. Formula. The EMF E is the potential difference PD across both external and internal resistance. If R, capital R, is the total external resistance and small r is the internal resistance, then electromotive force E is equals to IR plus IR, where IR is the drop and IR is equals to V. I is equals to E all over R, big R plus small r. Since E in bracket E minus capital V is equals to potential difference across internal resistance R, small r, then the current is given by I equals to capital E minus capital E all over capital R. Note, potential difference V is equals to capital E minus capital I small times small r.